Welcome to Chapter 7, Lesson 3, Part 2 for Physical Science Tolker's class. Chapter 7, this is Lesson number 3, and this is Part 2. So we're going to begin by solving some problems. We'll be solving problems dealing with kinetic and potential energy. Here's the example. A 2-kilogram rock is at the edge of a cliff 20 meters above the lake. It becomes loose and falls toward the water below. Calculate its potential, kinetic, and what it is at the top and halfway down. Its speed is 14 meters per second at the halfway point. So this particular problem has several things that we'll be doing to it in order to solve it at the end. A couple of things that we're looking for. We're looking for kinetic energy, potential energy, kinetic and potential halfway down. Here are some of the givens. The mass of the rock is 2 kilograms. It is 20 meters above the lake, and our velocity is measured to be 14 meters a second, about halfway down. At the bottom, you can see our formulas or our relationships. Hopefully, you have these relationships or these formulas in your word maps, also on your best friends. Where we solve for potential energy is mass times acceleration due to gravity times height. Solving for kinetic energy is 1/2 the mass times velocity squared. We're going to assume the starting position of the rock is at rest. So let's go ahead and start this off. First, we're looking for the kinetic energy of the rock at the top of the cliff. Kinetic energy, potential energy, halfway down. Remember, you should be able to use your best friends. Your best friend has the formulas to solve for kinetic, potential, and when you have something that's about halfway down. Here it is here. So the first part of this we'll be solving for potential energy. Potential energy is mass times acceleration due to gravity times height. And over here you have everything else that you need. Potential energy is measured in joules. Mass of the item will have to plug in the mass of what the rock before it falls, as well as the g, which is acceleration due to gravity. G, acceleration due to gravity, is 9.8 meters per second. For kinetic energy, it's a little bit different. For our kinetic energy, we have everything that we need right here. Kinetic energy equals 1/2 the mass times the velocity squared. Okay, so let's go ahead and start solving these problems. We're going to start at the top. We know the mass is 2 kilograms. We know the mass is 2 kilograms. We know gravity on the planet Earth is 9.8 meters per second. And we know the height over the top of the ground is 20 meters per second. So all you do now is plug and chug the numbers. We know that energy of potential, or potential energy, is mass times gravity times our height. So we're simply going to plug those in. 2 kilograms is our mass. Acceleration due to gravity is 9.8 meters per second, and we happen to be about 20 meters over the ground. Just plug that in your calculators. You should find your answer being about 293 joules. Now let's solve the other problem. The other problem is at the top we still have the mass of 2 kilograms. Velocity at the start, of course, at rest is 0 meters per second, and then we will plug in the numbers. What's the kinetic energy at the start? So the let's go back, at the start or at the top. Let's go ahead and figure that out. Kinetic energy is equal to 1/2 the mass times the velocity squared. So, half mass times velocity squared. Our mass is 2. Half of 2 is 1. We have 1 kilogram mass. The velocity of the start is 0 meters per second. So 0 times that is that. So your particular answer should be 1 kilogram. 1 kilogram times 0 squared will give you 0 joules at the start. Now let's talk about halfway down. At the halfway down, some of our givens are still what we have listed here. Our givens are 1 kilogram mass. Gravity is still 9.8 meters per second. The height over the top of the lake is 10 meters. Now we're going to solve for this, the potential energy that it could have and the kinetic energy that it could have about halfway down. So the potential energy, the energy of potential is m times g times h. So we're going to plug in the stuff that we know. Our mass is 2 kilograms times acceleration due to gravity, which is 9.8, times our height, which is 10 meters. This will give you, because halfway down. Now, here's the part if you didn't get what I did there. The total distance was 20 meters. I took half of that. I took 1/2 of the 20 meters, which gives us 10 meters. So, my joules is 196 joules, about halfway down. Let's figure out the kinetic energy about halfway down. The kinetic energy, here's the formula for kinetic energy, where kinetic energy is 1/2 mass times the velocity squared. Halfway is 10 meters. Our mass is still 10 kilograms. At that particular distance, my velocity is going to be 14 meters per second. Then I'm going to plug and chug the numbers. At the halfway point, the total way was 20 meters. Half of that is 10 meters. Half the mass times the velocity squared. My mass is 2 kilograms. Half of that is 1 kilogram. So let's plug it in. 1 kilogram times that particular speed, 1 kilogram times the speed per meters per second. Remember, ladies and gentlemen, the velocity is squared, so it's 14 times 14 first. So 1 times 14 squared gives us about 196 joules. What did we notice about the kinetic energy and the potential energy halfway down? We should have noticed that they were equal. They were equivalent. Because half of the energy had been changed from potential energy to kinetic energy, and it still had halfway to go. So this is what it looks like. You can draw a free body diagram if it helps you understand it. We figured out the total joules at the top, 392. We figured out the potential energy halfway down. We figured out 0 was our joules at rest. And we also figured out how many joules it was halfway down. That was a complex question. So that brings us to the end of our Chapter 7, Lesson 3, Part 2. Now it's time for you to go to the quiz that's in the book, where it would be Chapter 7, where it would be Chapter 7, Lesson 3, quiz. All right, thank you for paying attention. I appreciate your time. Have a great day.